Okay, so now we're moving on, and we will welcome uh, Maytham Alfouadi and Sudeep Goswami. This session will be about 5 critical pillars of modern API management you must consider. So, guys, welcome. Thank you for being here. We're very happy to have you here. And we can start by introducing yourself, please, and then the floor is all yours. Thank you.
Hi, everyone. Pleased to be here. My name is Sudeep Goswami. I'm the Chief Revenue Officer here at Traefik Labs.
Hi, everyone. My name is Maytham. I'm a solution architect here at Traefik Labs.
All right, I think we can go ahead and get started with the presentation. Hello, everyone. So the topic for today is going to be next generation API management, and we're going to share with you what we believe are the 5 critical pillars that you must consider when you're looking for a new API management solution. This is going to be a 2-part presentation. So myself and Maytham, I'm going to go through a quick 10-minute presentation on the topic, and then I will hand it over to Maytham, who is going to do a live demo for you guys. So a little about Traefik Labs for many of you that may not have heard of us. Traefik Labs really started as a cloud native company in the cloud native era. And this was, I would say, probably 5-6 years ago. And we are very fortunate to have had very like an amazing traction with the open source community. And to date, we've had over 3 billion downloads with over 40,000 stars on GitHub. We have a very vibrant community of contributors to the open source project, which is numbering over 700 as we speak. And we have had hundreds and thousands of nodes that have been deployed in production. And a lot of this really started with our first product in our product journey, which was Traefik Proxy. And at the time, this was the industry's first cloud native ingress controller. And then we quickly followed that up with an enterprise version of that product based on demand from customers. And that added more capabilities around access control or security, high availability, and with mission critical support. And that product was called Traefik Enterprise. And then most recently, we have launched the industry's first Kubernetes native API management solution. You can find more information on our website on any one of these 3 products. So let's talk about the discussion today, which is about API management. And when we look at API, I think this should be no surprise to all of you listening here. The growth in APIs that we have been witnessing over the past many years, it's totally undeniable, whichever way you look at it. And it doesn't look like it's going to stop anytime soon. And if you just look at some stats from the industry, Akamai publishes a stat that they look at all traffic going through the internet, and they find that over 80% of that traffic comprises of API requests. Similarly, IDC did a study, and they found that 90% of digital services that are being built using public and internal APIs. And then there was a study done of developers asking them how they spend their time. And again, no surprise here, over 50% of their time is being spent on third-party and partner-facing APIs. So clearly, you can see the scale and the growth trajectory of APIs. And then one last data point on this: there was a survey done of organizations asking them whether participating in the API economy is a top priority for them. And no surprise here, 60% of them said yes, it is a priority right now, and we're actively working on it. And another 16% said it is not a priority today, but it is going to be very soon. So you can see almost 3/4 of the organizations clearly see API as a priority for their organization. So when we talk about APIs, and we almost have to kind of think of that as a continuum, as a life cycle. And when you look at the API life cycle, it in its very nature is multifaceted. It is not composed of just one particular activity. You have, from the starting point, a design of an API, all the way at the very end where you're actually publishing and sharing those APIs through a portal with your internal developers or your third party, your partners or other external constituents. So when you look at the continuum of this API lifecycle, it is, is very, I would say, wide. The scope goes all the way from design to testing to mocking to runtime, which is where the gateway and the security and the portal comes in. And what we have seen in the industry of the types of solutions that are offered, they kind of fall in two different buckets. You have vendors that are trying to provide an all-in-one solution where they go through all of these, they check all of these boxes, and they try to provide a solution that caters from design to portal. And then you have a different set of vendors that are picking and choosing the areas that they want to focus on. For example, API design could be one, or API testing and mocking could be another portion. So this is where kind of we see a bifurcation in the industry of two different types of vendors. Now, clearly, best of breed offers a lot of capabilities, but what happens with best of breed is the onus is now put on the user to be able to bring everyone together and make sure there is there's good interoperability. And with the all-in-one solution, it creates another set of problems. And we want to talk a little bit about that here, because what most of these platforms that try to provide all of these various components in one big colossal stack, the challenge with that is most of these companies were built the pre-cloud native era. So their solutions tend to be very proprietary and monolithic. And they almost come with an all or nothing consumption mindset, where it is very hard to pick and choose. For example, if you just wanted to use their runtime or their API gateway, but you don't want to use their design and their testing capabilities, it's very hard to kind of parse it all out. You have to use it all or nothing. And typically, these come with a very heavy tech stack. So you have to install a whole bunch of different applications. You may have to install the front end. You may have to install a database, and it becomes very hard to maintain. Also, with these all-in-one solutions, they tend to not align with the DevOps operating model, which has become the de facto model for all API shops. And these operating models are very UI-centric, which means they come with a very point-and-click workflow. And even though some of them try to provide scripting and CI/CD capabilities, they are extremely limited. And when you're switching from a UI workflow to a scripting workflow, they don't always kind of align with each other. And sometimes there's conflicts. And then the onus is on the user to be able to address those conflicts. And then last but not least, most of these heavy monolithic solutions are very opinionated in terms of how and where you can deploy them. They're typically tied to on-prem installations, but the cases where they are tied to cloud installations, there is a very strict limitation on them being able to use it on certain clouds. So for example, you may only be able to use this on AWS, or you may only be able to use this on Google Cloud, and vice versa. And last but not least, these deployment flexibility also creates challenges. So many organizations that have a multi-cloud strategy where they want to have on-prem installation, they want to have cloud installation, but also they want to have installations at the edge. This creates a bigger challenge in terms of the flexibility. So all of these three things combined drives the total cost of ownership high. It creates the operator burnout because operators are not able to leverage these automation and scripting capabilities to ease their lives. And ultimately, it creates delayed time to value for the business to be able to reap the benefits of an API management solution. So we believe at Traefik Labs, having seen the industry from the early days of having an ingress controller and talking to them about API management challenges, we believe there are like 5 critical pillars that anyone should look at when they're considering a modern API management solution. The first pillar, it's really about choice and the freedom of choice. And this is a multidimensional aspect. The choice should start from having the choice around the API method. So whether it's HTTP, whether it's gRPC or something else, that's where it starts. But then also it goes beyond that, and the freedom of choice should exist at the ingress controller level. So customers are able to mix the best of breed functionality together. They should be able to deploy this anywhere. So whether it's on-prem, whether it's cloud, whether it's the edge. And then it should use industry standard specs like OpenAPI and OpenTelemetry. So as you can see, the freedom of choice is multidimensional, and a best modern API management solution is going to provide many of these choices. The second pillar is around DevOps being a first-class citizen, and the modern API management solution embodying DevOps into its product rather than having a bolt-on approach. And this is where everything that is done, all operations that the modern API management provides, comes with a CI/CD mindset, comes with a GitOps as a mindset, comes with config as code out of the box, and being able to integrate with tools, leading tools in the industry like Terraform or Argo CD should not be a big surprise. That should just work natively out of the box. Third pillar is around being security first. Security should also be not an afterthought, but it should be embedded into the platform. Having said that, there are some security functionality that should be embedded out of the box, things such as authorization and authentication. So being able to provide OAuth, JWT, RBAC support should be built into the platform. But then the platform should allow for third-party integration with best-of-breed products to enhance the security and to add to the security. So to be able to do OWASP API top 10 analysis, or to be able to integrate with third-party behavioral models or third-party leading companies that do behavioral model on API threat vectors, those become increasingly important. Fourth is being Kubernetes native. This is a very critical pillar, and this is about going beyond cloud native, and being cloud native in the world of API management is not enough. So you have to go beyond cloud native and be Kubernetes native, because it brings a lot of benefits to customers who are deploying Kubernetes in their environment. And what this means is you are deeply integrated into the Kubernetes API. So you get the benefits of that with things such as auto discovery of services. So no phantom services would exist anymore in your environment. You get 100% CRD support. You can use things such as labels and selectors to make your operational lives better. And by design, being Kubernetes native, you get HA and you get the ultra lightweight aspect. And then last but not least, the fifth pillar, you could do all four of these pillars, but if you don't make sure that you do justice to the fifth pillar, then all of this is going to be in vain. And that's why the fifth pillar is about making sure everything that you do drives value in a quick and efficient manner. And this should cater not just to advanced Kubernetes users or advanced API management users, but also to basic or people that are just starting this journey. So to be able to provide this dual operating model, and by that what we mean is to be able to have the UI point and click operation to get started quickly, but then also making sure that it aligns perfectly with an advanced mode user who may be starting with CRDs or starting with code. So to be able to take what the UI does, auto-convert it to code on the back end, and having this quick time to value concept is extremely important. Now, we can talk about these 5 pillars, but it would be incomplete without talking about an architecture that brings these 5 pillars together. And so here's a reference architecture that we believe is a great one. I mean, we have used this ourselves, but just to share this with you guys, the architecture has to be modern, has to be lightweight and open. And it really starts with having this notion of a central control plane that could be fully hosted and managed in the cloud, but giving the flexibility to connect to the data plane that could run in any environment. So having this deploy anywhere concept come alive with this type of an architecture. And in this example, what we're showing is you have a central control plane running in the cloud that is connecting to 3 different clusters, and each cluster having a different configuration and a different personality. Cluster 1 is got an ingress controller that is Traefik proxy. Cluster 2 has ingress controller, which is Nginx, and cluster 3 has an ingress controller that is HA proxy. All these 3 environments are Kubernetes native, and they have different services running, but they all can be managed centrally and publish APIs to a central control plane. We believe this is the type of architecture that actually would do justice to the 5 pillars that we mentioned before and give users an unprecedented level of choice with full 100% GitOps compliance and deliver the fastest time to value. And what I'm going to do is now hand it over to my colleague Maytham, who's actually going to do a demo of some of these capabilities and some of these pillars that we just talked about.
All right. Okay. Hi, everyone. So today I'm going to walk you through TrafficHub, industry first Kubernetes native API management solution for publishing, managing, and securing APIs with support for Traefik proxy and third-party ingress controllers like Nginx. TrafficHub dashboard is our interface for our controller plane, which is hosted in the cloud and fully managed by Traefik Labs. From the dashboard, you can quickly have an overview of your how many APIs do you have across all your clusters, how many collections that you have, how many portals already created, number of groups and users that you define in your dashboard, and also give you a quick overview of the portals and APIs that you recently created and recently published. From cluster agent view, you can quickly see that we have multiple clusters currently managed by TrafficHub. All these clusters are hosted and on different cloud provider. You can see that we have a Kubernetes cluster is living on AWS with the Traefik ingress controller. Another cluster is on AKS with the Traefik ingress controller. We also have an edge deployment with Rancher K3s that's running with the Traefik, which is the default ingress controller. And also we have a GCP Kubernetes cluster with Nginx ingress controller. So as you can see, we have we give you the freedom of choice of deploying your APIs anywhere you want, and you should be able to, regardless of your ingress controller stack, and you should be able to manage it quite easily through Hub. If you select one of the agent, that will give us more information about this particular Kubernetes cluster. You can quickly have a list of all APIs that is currently deployed on that cluster, the control access control policy that's currently defined that's on this particular cluster, and all the services that is running. Since we are Kubernetes native, we integrate directly with the API server, so we could get exact the same visibility that the API server has into our stack. If you look at the APIs, you can select the API and get more information about the backend service and what the ports and information that it's using, or you can create an API directly from the dashboard for quick time to value. And if you can see, it's quite simple. You just need to define a name, specify which cluster do you need this API to be run, created on. You select the service. Because we have an auto discovery of the services, you can see that we have you can get the exact service that you need to publish. If you have multiple namespaces, a service with the same name on multiple namespaces, you can select the exact service without any confusion. Once you select it, the system automatically detects which port is running on, so it avoid any mistakes when you try to publish the API. You can define the prefix and how you want to the service to be displayed in your API developer portal. You specify your API open API spec file, and then you define labels just for better manageability and usability of these APIs. So once you create the APIs and you have all these APIs created, sometimes you want to have them in a bundle for better usability and manageability of these APIs. So we created a collection where we selected a label, a key value pair that we want to have these APIs bundled based on. And you can see we have only 3 APIs that match that label combination. Once you have your API collection created so that you can reference when you try to give access, we have the portal access, which basically we can use to define our API access control policy to prevent unauthorized access to these APIs. Using the API access policy, you can create restrict access to particular user and groups to these APIs. Here in our demo, we had an admin group that have pretty much access to all our APIs that deployed on this cluster. But then we wanted to have a specific group that only have access to the collection. In the CRM internal group, it only have access to the specific API, and the last group, which we used it as an example as a support, it has only access to those 2. If we use one of the authorized account to try to access our API developer portal, probably should have logged out. This is an account that I already created. And you can see that this account, because it has access, I used this specific account has only access to the collection. We have only access to this specific collection, which consists of 3 APIs. From the API developer portal, you get a full view of all your APIs that is allowed to you with all the endpoints that you can interact with. Each of these APIs is automatically protected using JWT. You just need to create, once you log in, you just need to create a new token. And then you use that token to authorize with the, and then you should be able to interact directly with these APIs. So everything that we have done so far through from the portal, from creating the APIs collection, even creating the portal, you can do this using CRDs. Since we are Kubernetes native, you basically just need to define our APIs using CRDs. And as you can see, it's quite simple. You just similar to what we did in the UI, you define the name, you assign labels, you associated with the service, specify the port the service is using on, and then you define your API collection based on the labels that we define for our APIs. You define an API access policy to restrict access to your API to specific user and group. And finally, you define your API portal, in which basically will allow you to interact with these APIs. Once you have all these definitions ready, you can provide it to your the GitOps tools like Argo CD or Flex CD, and you should be able to publish, manage, and secure your APIs in seconds. And this is basically what I've done in my setup. I've had everything hosted in my GitHub repository, and I just used Argo CD to deploy it in my environment. Since TrafficHub is based on open standard, we integrate with all the application, the standard applications. So in this case, we integrate with a Grafana to monitor all the statistics of our APIs out of the box without any special tools. So to recap, what we've done so far from the TrafficHub dashboard, we were able to manage our clusters regardless where they're hosted and regardless of the ingress controller stack. We can create our APIs using UI or the CLI using CRDs, and regardless where you create it, it will sync automatically. We created our collection for better manageability of these APIs, and then we define our portal access so we can interact with these APIs. We protected our portal using OIDC, and we protected our API using JWT. And that's a quick walkthrough of the TrafficHub dashboard.
Thank you, Maytham. So I think that wraps up our presentation. You guys saw why it is important to talk about the 5 pillars, and you also saw a demo of the 5 pillars. So over to you, Mariana.
Thank you so much. Sorry for the delay. Thank you so much. Yeah, the 5 pillars, I think it was very clear. It was very interesting. I think me and the audience might have some questions, but I'm sure that we will be able to contact you separately. We already have your emails on our program, and we hope to see you in a future event of API Days. Thank you so much, and we're going to have a lunch break, and we'll be back at 1:15 for the audience to join us a little bit later. Thank you, and see you later.